Good morning, friends. I welcome you all to our online C classroom. So, today in this class, we are going to see some of the important programs which were asked in the previous examinations. These are very simple and basic problems. Usually, at the beginning of the C language, when you are learning C language newly, these programs are taught, but these programs were there in unit 5. All these programs, their names have been specially mentioned in unit 5 of RE18, means your syllabus. So therefore I thought that it is very good and beneficial to you if I discuss these programs with you. So because of that reason, today I have come with these programs to discuss with you. So I request all of you to concentrately listen to these programs, because these programs you may get in your end semester examinations. These are very simple. I think most of you have already done as a lab exercise in our laboratory. So what are these programs? These programs are very simple programs. One is determining the roots of a quadratic equation, and then determining whether a given number or integer is prime number or not. And the third program is printing all the prime numbers in a given range. And the final program that we discuss in this class is determining the biggest and smallest numbers in a given set of integers. So these are the programs that we will discuss for today's class. So let us start with determining the roots of a quadratic equation. This is our first program. Already pseudocode and algorithm is given to you in the last class. Now we will discuss a C program. How to write the C program for determining the roots of a quadratic equation. The same pseudocode I have converted into the programming statement. So therefore, if you have already gone through the pseudocode, then you can easily understand this. There is no problem for it. Program is very simple. See, quadratic equation means it is in the form of ax square bx plus c is equal to 0. So in the school level mathematics already you have studied a quadratic equation of the form ax square plus bx plus c is equal to 0 is having two roots. The two roots are determined using the formula minus b plus or minus under root of b square minus 4ac all divided by 2a. So this is the formula. The same formula we are going to use in our program to determine the two roots of this quadratic equation. So in equation ax square plus bx plus c equal to 0, here you know that a, b, c are constant values. They may be integer values or they may be real values, but here I have taken them as integer values. So therefore I have declared a, b, c variables as integer variables in our program. And then since we are determining the roots using a equation of the form minus b plus or minus underscore under root of b square minus 4ac all divided by 2a, so you may get real values as your roots. So therefore these two roots I am calling them as R1 and R2. I declared them as real values, means in C language they are float. Real values are represented using float data type or double data type or long double data type. Here float data type is enough for us. Now we will ask the user to enter the values of the constants a, b and c values. Since we have declared them as integers, we are instructing the computer to read decimal integer, 3 decimal integer values from the user and store them in variables A, B and C respectively. Now we use the formula of determining the roots. That formula I have written here, R1 is equal to minus B plus SQRT function we are using to determine the square root of b square minus 4ac. Enter the square root of b square minus 4ac. I wrote inside SQRT function, and it is a mathematical function we are using from math library. So therefore we have included math.h header file at the beginning of the program. You can observe here. So we have included math.h header file. Now R2, second root. So one root is with minus b plus, and now second root is minus b minus square root of b square minus 4ac divided by 2a. So this equation will be evaluated by the CPU, and it calculates the square root, and first root will be stored in variable R1 and second root will be stored in variable R2. So after obtaining R1 and R2 values, we are displaying the roots. Root R1 is equal to percentile 0.2f comma R2 is equal to, means the second root is equal to percentile 0.2f, means we are instructing the computer to display only two digits after the decimal point. The 0.2f represent that we would like to have only 2 digits after the decimal point. So therefore these are displayed, and then we have closed the program, returned 0 because we declared main function as it is returning integer to the operating system. So therefore we wrote return 0, and then main program is closed. So this is how you can write the program for determining the square root of a quadratic equation. It is very simple. Already many people used it in the laboratory. So check your program whether you have written program as per the statements we have discussed here. Okay, so then let us proceed to the next program, determining whether a given integer is prime number or not. So I think most of you have know the definition of prime number. What is the prime number? Prime number is an integer value which is divisible by 1 and only itself. No other number can divide the primary number except 1 and itself. So to determine whether a given number is integer, given integer value is prime number or not, what we have to do is we will take an integer value from the user. Usually only positive integers are represented as prime numbers. If the user enters negative value, then immediately we will check the value after receiving from the user whether that value is positive integer or not. If the user gives any negative integer value, means any value which is less than or equal to 0, we don't accept that value. We have to accept only integer values greater than 1 from the user. And then after determining that, after confirming that the number given by the user is a positive number, if the user doesn't give positive number, then immediately we will display the message to the user that the user has to enter only positive number. If the user enters negative number, we will display this error message and immediately we will terminate the program. Suppose if the user enters a positive number, positive integer value, then we try to divide that integer value from the integer 2 and up to n minus 1. Whatever integer value that given by the user, we are storing that value in an variable n, and we start dividing that n with all the numbers right from 2 to n minus 1. And if any number divides n between 2 and n minus 1, and whatever number is dividing n, immediately at that number we will stop and we will say that n is not prime number. Why? Prime number is not divisible by any number. Means if there exists any number between 2 and n minus 1, then we say that n is not prime number. And if no number divides n between from 2 to n minus 1 value, then we know that since no number has divided that n, so therefore the given value n is a prime number. So this is the simple logic for determining whether a given number is prime number or not. Let us see how we did the program. See here, in the main program we have included stdlib.h. This header file is included because we are going to use exit 0 function in our program. Already I told you that as soon as we read the integer value from the user, we will check whether the user has given positive integer value or not. If the user enter negative integer value, then immediately we display an error message to the user and we will terminate the program. To terminate that, we will make a call to exit 0 function. Since the definition of exit 0 function is defined in the header file stdlib.h, so we have included this header file to our program. If you are not making use of exit 0 function, then there is no need to include this header file to our program. Now let us see. We have declared two integer variables. One is I and n. I is used as a loop control variable whose values are going to change from 2 to n minus 1. And then n is used as a variable to store the integer value given by the user. And this n value we have to test whether that is a prime number or not. Let us ask the user to enter an integer value. Then we will instruct the computer to take or read that integer value and store in variable n. As I told you, first we will check whether the user has given positive number or not. If the user enters negative number, then immediately we will display error message and we will stop the program execution. So here we are checking the condition. If n value is less than or equal to 0, we know that the integer given by the user is a negative number. So therefore, we are displaying a error message to the user that saying that enter only positive integers. Then immediately we are terminating the program by making a call to exit 0 function. Suppose if the n value is not less than or equal to 0, then this condition becomes false. Then this statement is not executed. Then it goes to the next statements in the program. What are the next statement written in the program? See here, the next statement written is if n value is equal to 1, means user may enter positive integers, means positive integer starts from 1. So therefore, there are chances that user may enter value 1. You know that 1 is not a prime number. Immediately we are displaying that it is not a prime number and we are stopping the program. And there are chances that user may also enter a value 2. If the user enters a value 2, we will display the message to the user that it is a prime number and immediately we are stopping the program. Because we know 2 is the first prime number and it is only the prime number in even numbers. Except 2, no other even number is a prime number. And all except 2, all other prime numbers are odd numbers. So therefore, exclusively I have written statement to print the message that by mistakenly sometimes user may enter a value 2 also. So we have to display the message to the user saying that it is a prime number and immediately we are stopping the program. No other part of the code is executed. If the n value is greater than 0 and if n value is not equal to 1 and not equal to 2, then if n value is greater than 2, then it is coming here. Now we are going to check here whether that number is a prime number or not. The logic is already I explained. We start dividing that number from 2 to up to n minus 1. So each time we are going on dividing n value with the I value. Here we have to write if n percentile I. Initially I value starts with 2. I wrote 2. So this is not 2. Just replace this 2 with I. So it is n percentile I is equal to 0. Initially I value is 2. Since we are having here I, its value is 2. it divides n with 2. If that is equal to 0, remainder equal to 0, then immediately we are coming out of the loop, and then here we are so this is something wrong, determining whether a given number is prime number or not. So I written the code, exact code there. So here we can remove this part of the code. Just remove this part of the code. It is not there, because the same statement I have written in the next slide. I forgot to delete it. See, don't write this code. So go to here. Here we are determining whether a given number is prime number or not. See here how we wrote. We have started with the 2 and we are going up to I value n minus 1. Means we start dividing n right from the number 2 to up to n minus 1. Then see, first I value starts with the 2. If n divide percentile 2, if it is equal to 0, we are immediately coming out of the loop, and here we are checking whether I value is equal to n or not. We know when I value reaches n, when I value is equal to n, I value is equal to n only when no number divides from 2 to n minus 1. No number divides n, then only I goes on increasing, finally I reaches n. When I value becomes n is less than or equal to n minus 1, becomes false, and then it will come out of loop. If I value is equal to n means it is a prime number. Given number is a prime number. We will print that message. If I value is not equal to n means you have come out of the loop before I reaches n. Before I reaches n, when you will come out of the loop, when there exists a number which can divide n with I and gives remainder 0, means there is existing some integer from 2 to n minus 1. That number divides n so that you will be getting remainder 0, means that number is not a prime number. So that is what we are checking here. When you are after the loop execution is over, immediately we are checking I value. From I value we can confirm it. If I goes up to n, then we know that it is a prime number, because no number is existing from 2 to n minus 1 which can divide n. So therefore you can display the message that this number is a prime number. And if no number divides that number, then we can say that this is not a prime number. Just to look at the loop, how it is going on executing. Initially I value is 2. If n divided with 2 is not equal to 0, then this statement becomes false, and then I value becomes 3. 3 is less than or equal to n minus 1 if it is true, and then it enters into the loop and divides n with 3, checks the remainder. If the remainder is not equal to 0, then this statement becomes false, then I becomes 4. 4 is less than or equal to n minus 1. Like that this goes on executing. If n value is, suppose say user has given n value as 17. 17 minus 1 means 16. User has given, assume that n value as 17. 17 means we have to check whether 17 is a prime number or not. Then I will go up to I is less than or equal to n minus 1, means 17 minus 1, 16. I will change up to 16. Finally it divides n, means 17 with 16, and found that the remainder is not 0. Then I becomes 17. 17 is less than or equal to 16. It becomes false. Then it will come here. Since I value is 17, 17 is equal to n value also 17. Then immediately it will display that the given number is prime. So like that we are going on dividing n value from 2 to n minus 1. If any integer from 2 to n minus 1, if any integer divides n, then immediately we are stopping the loop and coming out of the loop and checking I value. If I value is not equal to n, we can confirm that it is not a prime number. This is the simple logic of the program. Then little modification to this program is printing all the prime numbers in the given range. In this program we ask the user to enter starting value of the range and ending value of the range. User may give starting value may be 100 and ending value of the range may be 400. In this case the range is given as 100 to 400. We have to determine how many prime numbers are there between 100 and 400, and all that prime numbers we have to display to the user. The program is very simple. the logic is we will start from 100. Goes on dividing 100 means we have to check first. We start with 100 because the range is starting from 100 and going up to 400. Each number, each integer we will take from 100 to 400 and test whether that number is a prime number or not. To test whether that number is a prime number or not, same logic we will use. First we will start with 100. We will check whether 100 is a prime number or not. How do we check? By dividing 100 with all the numbers starting from 2 to up to n minus 1. N minus 1 means here n value is 100. So n minus 1 means up to 99. We go on dividing that number, each integer 100 with 2 to right from 2 up to 99. If any number divides 100, then immediately we will stop and say that 100 is not the prime number. We don't display here. Only we will display prime numbers. We confirm that 100 is not a prime number. So therefore we go to display value 100. And then we will go with the next number. Next integer is 101. Same thing we will do. 101 we will check whether it is a prime number or not. If we confirm that it is a prime number, then we will display that 101 and go with the next number 102. And again we will check 102 whether it is a prime or not. If it is not prime and we don't display 102, and then we will go with value 103. Again we will test 103 using the same logic. If 103 found to be prime, we will display it. Otherwise we will continue with the next number. So this is the logic that we use. And already I told you that prime numbers are all odd numbers, not even numbers. So when you come across any even number between 100 and 400, directly you can say that it is not a prime, because all even numbers are divisible by 2. So therefore all even numbers are not prime numbers. So that also you can eliminate all the even numbers, only you go on testing only odd numbers. So it will save a lot of time, means 50% of the work you can avoid. But here we have tested every number, positive numbers and even numbers and odd numbers, both we have tested in this program. But if you want to reduce, if you want to improve the speed of your program, directly only in the given range you consider only odd numbers, not the even numbers, because we know even numbers are not prime numbers because they are divisible by 2. Let us see the program. We have declared I, j, n1, n2. I, j are used as the loop control variables, and n1, n2 are used to store the starting value of the range n1 and ending value of the range is stored in variable n2. Then we will ask the user to enter the starting value and ending value of the range. Enter starting and ending range of values to display primes. User will enter starting value of the range, ending value of the range. So those two integers we are instructing the computer to read and store in n1 and n2. n1 contains the value of the starting of the range. n2 stores the value of ending of the range. Now our job is to determine the prime numbers and to display all the prime numbers in that range n1 to n2. First we are displaying a message, the primes in the given range from percentile to percentile d. Percentile d to percentile d. At the first percentile d, n1 value is displayed. At second percentile d, n2 value is displayed. And then we are checking here the prime numbers starting from n1 to up to n2. I is going on checking, taking values from n1 to n2. When I value equal to n1, we divide I value with all the numbers from 2 to up to n1 minus 1. I minus 1. Okay. So if any number divides I value, then immediately we say that the present I value is not integer. So we are coming out of the loop. There we are checking whether j is reaching I. We know when j can reach I only when no number divides. No number divides from 2 to up to I minus 1. No number divides I. Then only I is a prime number. So if I value j value is equal to I, then only it is a prime number. We are displaying that I value as prime. Otherwise we are not displaying anything. I will go with the next value. I value is incremented, means n1 plus 1, and again n1 plus will be divided with all the numbers from 2 to up to n1. So like that it goes on dividing. and wherever it come, no number is divisible. Whenever a number is not divisible with the numbers from 2 to up to I, so then that I value is displayed as a prime number here. So these two for loops will perform our task. This logic is same. Whatever logic we have used to test whether a given number is prime number or not, there we have tested only one number. So one for loop is required. Here we are having a set of values from n1 to n2. Outer for loop is used to keep track of the range of values from n1 to up to n2. So this is only the difference, a little modification. One more outer for loop has been added. Inner for loop is same as the previous program. So this is the third program, and then we will go to fourth program. Our fourth program is we are given a set of integer values. We will store them in the array, and out of that set of values we have to determine the biggest value and the smallest value in that set. It is very simple. Already we did this program separately, determining biggest of given set of values or array of values. We have written one program separately, and we have written other program determining the smallest of given array of values or set of values. Here we are combining both the things in one program, so that in the examination, if they ask only to write determine the biggest of given set of values, you can write the same program. And if they ask you to determine the smallest number in a given set of values, you can write the same program. So therefore I have combined both. I have taken two variables, big and small. Big always stores the biggest of given numbers. Small contains the smallest of all the numbers. I is used as a loop control variable. N will keep track of how many values are there, how many set of values are there, and all that given n set of values we are storing in the array X. We have declared an array X with a storage capacity of 20 elements, maximum 20 integer values. Now we are asking the user how many integer values are there. That value we are asking the computer to read and store in variable n. N value may be given by user as 10. If n value is 10, means user is having 10 integer values. Out of that 10 integer values, we have to determine which value is biggest and which value is smallest one. Then we are asking the user to enter all that values, integer values in a row. And here we are using a loop to read all that values and store in array X. And in the array X, all these integer values are stored from index number 0 up to index number n minus 1. So I is less than n means I can take values up to n minus 1, 0 to n minus 1, total n numbers. First element index number is 0, and last element, nth element index number is n minus 1. Now see, we are starting after storing all the values in the array, then we are assuming that the first element which is there at the index position 0, so that element we are thinking that it is, initially we are assuming that it is the small element, it is the big element. Then we will compare this value with all the other elements in the array. All other elements are there from the index number 1 to up to index number n minus 1. So therefore we are writing a for loop for I equal to 1 to maximum I can go up to I less than n means I can take value maximum up to n minus 1. So 1 to n minus 1. Remaining numbers are compared. How we are comparing? Already big value, we are assuming that first element. So whatever value is there in the big, if that value is smaller than the next element in the array, initial I value is 1, x of 1, means if big value is smaller than x of 1 value, we know that x of 1 is the big. So therefore immediately we are updating the big value with the x of 1 value, like that. If x of this statement is false, means if whatever value is there in the variable big, if it is not less than x of I, this statement is not executed and the big value will be returned as it is. And then we are comparing the same x of 1 element also with the value stored in variable small. If the small value is greater than x of 1 element, we know that x of 1 is small. If this statement is true, means whatever value is stored in variable small, which is bigger than the value of x of 1. So therefore immediately we are updating small is equal to x of 1. If the smaller value is not greater than x of 1, then the variable small value is not going to be changed and it will continue with the next element which is there at index position 2. I value becomes 2. 2 is less than 10 because we have assumed that n value as 10. in that case, I value at present 2. So 2 is less than 10. It is true. Again, big value and small values are compared against x of 2. Means whatever value stored at the index position 2 means third value. Like that. And if any things are if any one of these statements are true, big and small values may be updated. And then after that is over, I value becomes 3. 3 is less than 10. And then big and small values are compared with against x of 3. Means whatever value is stored in the array at index position 3. With that value, big and small values are compared. If any one of these statements are true, big value may be updated and small value may also be updated. And then I value becomes 4. So like that, I will go up to 9. I value 9. When I value is 9, 9 is less than 10. Condition becomes true because the last element will be there at index position 9. With that it is compared. After that, I value becomes 10. 10 is less than 10 becomes false. And then this loop will be stopped. Means by the time this loop is execution is over, big variable contains the biggest value of all the array of elements. And then small variable contains the smallest value of all the values of the array. Now we are going to display the given set of integer values which are stored in the array from index position 0 to n minus 1 we are displaying, and then we are displaying the biggest value and the smallest value to the user. This is how you can write the program. And when you are writing the program, wherever it is required, you have to use the comments so that the program can be easily understood by you when you see this program after 10 days or 15 days or 1 month or 2 months. And it is also for others to understand your program. For that purpose, we use comment lines. Comment lines means documentation. The documentation of the program is very, very important. So like that, you can write any programs. While writing the program, you follow the indentation. It is also important. So this is what the programs, these are the most important programs. You can just have a look about this program. Thank you for your patience. Thank you.